Welcome. Tonight, we're not trying to define time, measure it, or control it. We're simply slowing down enough to notice how deeply it has always been present. Long before clocks, calendars, or numbers, time existed as something felt rather than understood. It was not an abstract idea, and it was not separate from daily life. It arrived as change, as light fading, as cold settling in, as hunger returning. Time did not need a name to be real. It made itself known through repetition, and repetition quietly demanded attention. For early humans, time did not appear as a line moving forward, but as a rhythm that wrapped around life. Day followed night, night returned to day, and this cycle repeated with such consistency that ignoring it was impossible. Survival depended on recognizing these shifts. Movement was safer in light. Rest was necessary in darkness. Over generations, this pattern became instinctive. Time was not something you asked about. It was something your body already knew. One of the first moments when time became visibly noticeable was through the behavior of shadows. A shadow moves without sound, without resistance, without effort. It changes shape and position, even when nothing else appears to move. At some point, people realized that this movement followed a pattern. The shadow lengthened and shortened in relation to the sun, and the sun followed a path that returned again and again. Without intending to invent anything, humans began watching time travel across the ground. This observation did not require explanation. It required patience. Standing still long enough to notice that the same place looked different at different moments of the day. Earlier and later were not concepts yet, but sensations. The world felt different as light shifted. The meaning of a place changed as shadows moved. Time revealed itself not as a thing, but as a process unfolding quietly. Night altered this experience further. When the sun disappeared, visual markers vanished with it. Darkness compressed space and stretched duration. Sounds became sharper. Stillness felt heavier. Waiting for daylight was not a pause, but a condition that had to be endured. In the absence of light, time became less visible but more intense. It did not disappear. It thickened. The moon introduced a different scale of time. Unlike the sun, which returned each day unchanged, the moon transformed. It grew, shrank, disappeared, and returned. This slower rhythm offered a longer arc, one that could not be fully understood within a single day. People noticed that certain events aligned loosely with these changes. Animal movement, tides, and subtle shifts in the environment seemed to echo the moon's cycle. The moon did not explain time, but it made duration observable. Seasonal change made time impossible to ignore. Warmth gave way to cold. Rain disappeared and returned. Plants died back and re-emerged. These changes reshaped landscapes and demanded adaptation. For the first time, humans encountered time as something that could not be rushed or delayed. Certain actions only worked within certain windows. Planting too early or too late meant failure. Time revealed itself as something with conditions. At this stage, time was not counted. It was ordered. One thing came before another. One condition followed another. What mattered was sequence, not quantity. Time was relational. Meaning emerged from knowing what followed what, and from recognizing when something was out of place. As humans began to remain in one area longer, repetition sharpened awareness. The same land, the same paths, the same shelters allowed change to stand out more clearly. A winter felt longer. A drought felt harsher. Absence became noticeable. Memory stretched time backward, allowing comparison between what was happening now and what had happened before. With memory came loss. Some things did not return. Animals disappeared. People failed to survive a season. Time revealed a direction. It moved forward, carrying some things with it and leaving others behind. This realization introduced one of the earliest human mysteries. Why could time repeat seasons, but not lives? Why could it return warmth, but not people? Fire altered the experience of time without changing its structure. By extending light into darkness, fire stretched the usable part of the day. Night no longer meant immediate rest. It became a space for gathering, speaking, and thinking. Time felt longer, even though it was not. This revealed something subtle. Time itself had not changed, but the way it was experienced had. As language developed, time entered speech. Words like before and after appeared, not as measurements, but as orientation. Language allowed events to be placed relative to one another. This made planning possible. Promises emerged, and with them the assumption that the future would arrive as expected. Time became something intentions could travel through. Time remained local, not because humans failed to understand it, but because environments forced different solutions. Along coastlines, the most reliable rhythm was not the sun, but the water. Tides followed a predictable pattern tied to the moon, rising and falling roughly every 12 hours. Communities living near the sea learned to anticipate these movements with remarkable accuracy. Fishing, travel, and even rest were organized around tidal cycles, long before anyone understood the physics behind them. This was time experienced vertically, moving in and out, rather than forward. Inland communities followed a different logic. Without tides, seasonal change became the dominant clock. The length of daylight shifted throughout the year in a way that was impossible to ignore. Longer days marked periods of growth and labor. Shorter days demanded conservation and rest. Archaeological evidence from early agrarian societies shows planting schedules tightly aligned with seasonal solar patterns, even in the absence of formal calendars. Time here was horizontal, stretched across months rather than hours. These differences mattered. They meant that time was not universal. Two communities could live in the same year and experience it entirely differently. One followed the moon closely, another barely noticed it. One organized life around water movement, another around temperature and light. Time was shaped by necessity, not abstraction. The human body added another layer. Long before the concept of a biological clock existed, bodies followed predictable cycles. Sleepiness increased after darkness. Alertness peaked during daylight. Hunger arrived at regular intervals. Modern science now identifies these rhythms as circadian, regulated by light-sensitive cells in the brain, but early humans experienced them without explanation. The body kept time quietly and consistently. What made this complex was that the body's timing did not always align perfectly with the environment. In higher latitudes, long summer days disrupted sleep patterns. In winter, extended darkness altered alertness. People adapted behaviorally, not theoretically. They slept in segments, rested during the day, stayed awake longer at night when fire allowed it. Time became flexible in experience, even though the cycles themselves remained fixed. Evidence from ancient settlements suggests that segmented sleep was common. Rather than one long period of rest, people slept in shorter phases, waking during the night before returning to sleep. This pattern matched natural fluctuations in body temperature and hormone release. Time here was not a single block, but a sequence of states. As groups grew larger, coordination became more difficult. Informal cues worked well for small communities, but larger populations required shared expectations. This is where early attempts at synchronizing time began to appear, not through precise measurement, but through shared reference points. Sunrise gatherings, evening rituals, seasonal ceremonies tied to solstices and equinoxes. Structures aligned with solar events began to appear independently in different parts of the world. These were not clocks in the modern sense. They did not divide the day. They marked specific moments: the longest day, the shortest day, the return of light. These moments mattered because they anchored collective time. Everyone knew when they occurred, even if no one knew why they occurred exactly then. One of the most striking features of early time systems is how little they depended on numbers. Time was not counted, it was recognized. A solstice was not identified as a position in a sequence, but as the moment when the sun reached its limit and began to return. This kind of descriptive timing made events easier to remember and easier to share. Memory became the primary storage system. When rains arrived after a certain position of the sun one year, that sequence was remembered and expected again. This was not belief or superstition, but pattern recognition built through repeated observation. When those patterns failed, the disruption itself became meaningful. A season that did not behave as expected, animals that did not return, or warmth that arrived late were not forgotten. Time revealed itself not only through repetition, but through deviation. Change mattered most when it broke what memory had learned to anticipate. Fire and language quietly expanded this system. Fire extended usable hours into the night, altering rest cycles and compressing the boundary between work and darkness without changing external time itself. The experience of time shifted even as its structure remained fixed, revealing a difference between measured time and lived time that would later become central to scientific thought. Language allowed this experience to be shared across people and generations. Words for past and future made time discussable, transferable, and preservable through stories. Promises and plans depended on this shared expectation that time would continue in a recognizable way. Yet despite these developments, time remained uneven. Different environments produced different rhythms, and no single standard aligned them all. As trade expanded and travel increased, these mismatches created pressure. Coordination became difficult, intuition began to fail, and time slowly transformed from something merely noticed into something that needed to be aligned. As humans spent more time observing their surroundings, certain moments began to stand out more than others. Not every sunrise mattered equally. Some days felt different. The light lasted longer. Shadows reached unfamiliar places. These changes were slow, but consistent. Over time, people realized that the sun did not rise and set in exactly the same positions throughout the year. Its path shifted along the horizon. This movement was subtle, but it repeated predictably. In some locations, this shift became especially noticeable. Wide horizons, open plains, and elevated ground made it easier to see where the sun appeared and disappeared. People began to associate specific positions of sunrise or sunset with seasonal change. The longest day of the year, the shortest. The turning points between them. These moments were not measured, but recognized. To remember these moments, humans began to mark them. Not with numbers, but with place. Stones were positioned. Lines of sight were cleared. Openings were aligned. These were not clocks. They did not track hours or minutes. They acted as reminders. When the sun appeared here, something had changed. What mattered was not precision, but reliability. If the sun reached the same point each year, that point became meaningful. It allowed communities to anticipate seasonal shifts without counting days. Time was still read from the environment, but now with intention. These alignments also created shared awareness. When everyone could see the same event, time became collective. A moment was no longer personal or internal. It belonged to the group. This strengthened coordination. Activities could be prepared for. Movements could be planned. Importantly, this kind of time awareness did not separate humans from nature. It depended on it. Clouds could obscure the sun. Landscapes could change. Observation had to continue. Timekeeping was not automated. It required attention and memory. Memory played a critical role. Elders remembered where the sun had risen in previous years. Knowledge was passed through description and demonstration. Time existed through storytelling as much as through sight. The past informed expectations of the future. At this stage, time was still flexible. It was not exact, but it was no longer invisible. Humans had moved from simply experiencing time to actively watching it. They had not yet learned to control it, but they had learned where to look. This awareness marked a quiet transition. Time was no longer only something that happened. It was something that could be noticed together, remembered together, and anticipated together. And that change would soon make new questions unavoidable. At a certain point, watching time was no longer enough. As communities grew and daily life became more structured, the question slowly shifted. It was no longer only about noticing change, but about coordinating it. Knowing that the sun would rise was useful. Knowing when during the day something would happen became necessary. This was the moment when time began to move closer to tools. The sun remained the central reference. It was reliable, visible, and impossible to ignore. But its movement across the sky presented a challenge. While sunrise and sunset were clear, everything in between was fluid. Midday was not a fixed point unless it was deliberately identified. People began to notice that shadows reached their shortest length when the sun stood highest. This moment felt different. Light was harsh, shadows compressed, and heat peaked. It became a natural anchor. In ancient Egypt, this idea took a more deliberate form. Tall obelisks were not only monuments. They acted as massive shadow casters, dividing daylight into recognizable phases. Smaller shadow clocks followed, portable versions that allowed priests and officials to estimate time during the day. These devices did not tell people exactly what time it was. They told them where they were within the day's progression. This distinction matters. Early time tools were not designed to satisfy curiosity. They existed to manage behavior. Religious rituals required consistency. Administrative tasks required coordination. Timekeeping became tied to authority. Whoever controlled time references influenced daily rhythm. The sun, however, presented a limitation. It disappeared at night. Darkness erased shadows entirely. For societies that needed to regulate activities beyond daylight, this absence created a problem. The question became unavoidable. If time existed during the day, did it stop at night, or did humans simply lose their ability to see it? The response was not philosophical. It was practical. If shadows could not be used, another steady process was needed. This is where flowing substances entered the picture. Water moves continuously. Given a controlled container, it can be made to flow at a relatively steady rate. This insight led to the development of water clocks, known as clepsydra. The earliest known water clocks appeared in Egypt and Mesopotamia. These devices were simple. Water flowed from one container to another, and markings inside the vessel indicated elapsed duration. They were imperfect. Temperature affected flow rate. Wear altered accuracy. But they offered something new. Time could be tracked without reference to the sky. This shift was subtle but profound. Time no longer required observation of nature at every moment. It could be monitored indirectly. Duration became something that could be carried indoors, into enclosed spaces, into the night. Time began to separate from place. In ancient Greece, water clocks took on social importance. They were used in courts to limit speeches. A speaker was allowed to talk only while water flowed. When the container emptied, time was over. This practice reveals an important change. Time was no longer only descriptive, it was prescriptive. It enforced limits. This enforcement changed behavior. People adjusted their speech, their pacing, their expectations. Time began to apply pressure, not through natural consequence, but through agreed rules. This marked a transition. Time was becoming an abstract constraint rather than a natural rhythm. Despite these developments, early timekeeping remained approximate. No two devices behaved exactly the same. There was no universal standard. What mattered was agreement within a community, not accuracy across regions. Time was still local, even when tools were used. Parallel to these developments, the division of the day itself became more formal. Rather than simply morning, midday, and evening, daylight was broken into smaller named segments. In many cultures, these divisions were tied to work patterns, prayer times, or environmental cues. The idea that a day could be partitioned mentally prepared societies for more precise systems later. What's often overlooked is how much interpretation remained involved. A shadow clock did not announce its reading. Someone had to read it. Water clocks had to be monitored and reset. Timekeeping required attention. Forgetting to refill a vessel meant losing track entirely. Time was still fragile. This fragility preserved mystery. People could track time, but they could not fully trust it. Variations accumulated. Discrepancies appeared. Why did the same shadow fall differently on different days? Why did water flow faster in summer than in winter? These inconsistencies hinted that time was not as simple as tools suggested. Philosophers noticed this tension. In ancient Greece, Aristotle described time as something tied to motion and change, not as an independent substance. For him, time could not exist without movement. This idea reflected lived experience. When nothing changed, time seemed to vanish. Later thinkers questioned whether time flowed on its own, or whether humans merely perceived it through events. This debate was not abstract curiosity. It arose from practical frustration. Tools suggested regularity. Experience suggested variation. Meanwhile, in Rome, timekeeping became increasingly tied to public life. Sundials were placed in forums. Citizens could see the progression of the day. However, these sundials were often inaccurate, especially when copied from other regions without adjusting for latitude. Noon in one city did not align with noon in another. This inconsistency revealed a deeper problem. Time was not the same everywhere. Yet rather than discouraging timekeeping, this problem intensified interest. Adjustments were attempted. Calibrations were made. Observations were refined. Timekeeping slowly shifted from rough guidance toward deliberate correction. Importantly, none of this was driven by a desire to dominate time. It was driven by coordination. Trade, law, religion, and governance all benefited from shared temporal reference. Time tools were social instruments. Throughout this period, mystery persisted. Even as time was divided and tracked, its nature remained unclear. Did time flow evenly? Or did it speed up and slow down unnoticed? Tools suggested uniformity. Experience suggested otherwise. This gap kept time from becoming fully mechanical. Night remained particularly enigmatic. Water clocks could measure duration, but the experience of night still felt different. Time passed differently in darkness. This subjective quality resisted quantification. Even as tools advanced, lived time retained depth. By the end of this early period of timekeeping, when shadows and flowing water were first used as aids, humans had not mastered time, but they had clearly changed how they related to it. Time was no longer only something read directly from the sky or the landscape. It was now partially supported by simple tools. Shadows and water became practical collaborators, helping to divide the day into recognizable segments. The day was no longer experienced as a single, continuous flow. It had begun to acquire structure. This partitioning would have consequences. Once time could be divided, it could be owned, wasted, enforced, and optimized. But those consequences belonged to later stages. Here, time was still experimental, still imperfect, still tied to observation and interpretation. What matters most about this phase is restraint. Despite new tools, time was not yet standardized. Precision remained limited. Agreement mattered more than accuracy. Time was still human-sized, and yet the direction was set. From here, time would continue to move away from the sky and into mechanisms. The quiet collaboration between nature and tools would eventually give way to machines that ticked independently of sun and shadow. But that transformation had not happened yet. Time was still something you watched, something you listened to, something you managed with care. It was no longer invisible, but it was not yet absolute. Timekeeping tools did not immediately make life clearer. In many ways, they introduced new uncertainty. A sundial worked well on a clear day, but clouds could erase time entirely. A water clock offered duration, but its flow changed with temperature and wear. Early societies quickly learned that these tools were helpful, but not absolute. Time could now be followed, yet it still required interpretation and care. This dependence on observation kept time human-centered. Someone had to watch the shadow. Someone had to refill the vessel. Timekeeping was an active task, not an automatic one. This meant that time remained embedded in daily life rather than detached from it. Losing track of time was still possible. Forgetting to reset a water clock could erase hours. Time had structure, but it was fragile. Different regions adapted tools differently. In hotter climates, water clocks behaved unpredictably as evaporation increased. In colder conditions, flow slowed. These variations forced adjustments and local conventions. What counted as a fair duration in one place might not be accepted in another. Time was still negotiated rather than enforced. This negotiation shaped social behavior. In courts, assemblies, and rituals, time limits were understood as approximate. The goal was not exact equality, but perceived fairness. A speaker was given enough time to speak, not a mathematically precise interval. This reveals something important. Early timekeeping served social balance more than accuracy. The division of the day also remained flexible. Although daylight could be roughly segmented using shadows, the boundaries between segments were not rigid. Morning did not begin at the same shadow length every day. Seasonal changes stretched and compressed these divisions. People adapted intuitively. Time followed life, rather than the other way around. Night continued to resist structure. Even with water clocks, nighttime timekeeping felt different. Darkness altered perception. Activities slowed. Waiting felt longer. Measuring duration did not change experience. A vessel emptying in the dark did not make night feel shorter. This gap between measured time and felt time remained unresolved. Philosophers and observers noticed this difference. Some began to question whether time itself was steady, or whether steadiness was an illusion created by tools. If water flowed unevenly, was time uneven too? Or was time constant while tools failed? These questions emerged naturally from practical frustration, not abstract speculation. Despite imperfections, reliance on tools increased. The benefits outweighed the confusion. Activities could now be coordinated more reliably. Rituals could begin at similar moments each day. Public life gained rhythm. Time tools did not replace natural observation, but they supplemented it. The sky and the vessel worked together. This cooperation marked a quiet shift. Time was no longer entirely external. It was partially contained, carried indoors. Used at night, the environment still mattered, but it was no longer the sole authority. Humans had begun to intervene in how time was tracked. Importantly, this intervention did not yet imply control. There was no illusion of precision. Everyone understood the limits. Time was still approximate, still local, still dependent on care and agreement. But it was no longer invisible between sunrise and sunset. It had become something that could be followed more closely. By the end of this early tool-based period, time had gained shape without losing its uncertainty. Days were no longer seamless, but they were not yet rigid. Humans had learned to assist their sense of time, not replace it, and that distinction would shape everything that followed. Once time could be followed during the day, a larger problem quietly emerged. Days repeated themselves easily enough. Light returned. Darkness followed. But life was not organized only day by day. Crops did not grow in hours. Seasons did not turn overnight. Communities began to feel the weight of longer cycles, ones that stretched beyond immediate memory. This was the moment when time demanded structure on a larger scale. The most obvious long cycle was the moon. Unlike the sun, which appeared the same each morning, the moon transformed. It grew, thinned, vanished, and returned. This visible change offered a natural unit, longer than a day, but shorter than a season. Many early societies adopted the lunar cycle as their first way of counting extended time. Roughly one full cycle from one new moon to the next became a month, not because it was mathematically elegant, but because it was observable. Lunar time felt intuitive. The moon was easy to track, even without tools. Its phases were visible to everyone. A shared sky created shared reference. Over time, months acquired names, associations, and expectations. Certain activities were expected to happen under certain phases. Time became anticipatory. But the moon introduced a subtle problem. 12 lunar months did not match the length of the solar year. Slowly, almost invisibly, seasons drifted. Festivals tied to planting or harvest began to slide away from their natural context. At first, this shift was barely noticeable. Over generations, it became unavoidable. Time, when counted, began to slip. In regions where agriculture dominated life, this mismatch mattered deeply. Planting too early or too late had consequences. This pushed societies toward solar observation. The sun's yearly path through the sky defined seasons far more reliably than lunar cycles. In ancient Egypt, the solar year became central, anchored to the predictable flooding of the Nile. The year was divided based on the sun's return, not the moon's transformation. Other cultures attempted compromise. Instead of choosing between moon and sun, they tried to reconcile them. Lunisolar calendars emerged, keeping lunar months while periodically adjusting them to realign with the solar year. These adjustments were not theoretical. They were corrections born of necessity. This is where calendars truly began. A calendar is not just a way of counting days. It is a system for managing mismatch. It acknowledges that natural cycles do not fit neatly together and that human life depends on keeping them aligned. In Mesopotamia, this alignment became highly sophisticated. Babylonian scholars carefully observed both lunar phases and solar movement. They recognized that without correction, the calendar would fail its purpose. Intercalary months were introduced, added when necessary to keep festivals and agricultural cycles in sync. Time became something that required maintenance. As calendars spread, they absorbed culture. Months were named after gods, rulers, or seasonal activities. Years acquired meaning beyond number. Time began to carry narrative. It was no longer just when something happened, but what that moment represented. This symbolic dimension is especially clear in East Asia. In the Chinese lunisolar calendar, years were not only counted, they were characterized. The cycle of 12 animals assigned qualities to each year. A year was not merely the passage of time, but a temperament. The dragon year, the pig year, the tiger year. These names shaped expectation and memory. Time became descriptive. Importantly, this symbolism did not replace accuracy. The calendar still required astronomical correction, but it added a layer of meaning that pure measurement could not provide. Time became something people related to personally. Elsewhere, calendars took on political significance. In Rome, calendar control shifted with power. Early Roman calendars were irregular, subject to manipulation. Months could be extended or shortened for political advantage. Over time, this chaos demanded reform. That reform came under Julius Caesar. The Julian calendar aligned the year more closely with the solar cycle, stabilizing seasonal drift. While not perfect, It represented a major step toward consistency. The year became predictable across generations. Time gained continuity. This continuity changed how people planned. Long-term projects became possible. Historical records became more coherent. Events could be placed within a shared temporal framework. Time was no longer just local experience. It became collective memory. Calendars also reshaped identity. Celebrations anchored communities to shared moments. New years marked renewal. Anniversaries preserved history. Time provided structure not only to labor, but to meaning. Yet calendars remained human constructions. They required observation, correction, and agreement. Disputes over dates were common. Different regions used different systems. Time was organized, but not yet unified. What mattered was the shift in mindset. Time was now something that could be counted forward and backward. Years could be numbered. Past and future expanded. History became a sequence rather than a collection of stories. This expansion changed how humans understood themselves in time. Life was no longer experienced only as a sequence of immediate moments, but as part of a longer arc that stretched backward and forward. A single lifetime could now be placed within a wider temporal frame. Generations were no longer just remembered through stories, but positioned within counted years. The past became something that could be ordered, and the future something that could be anticipated with greater confidence. With this shift, comparison became possible. One generation could be weighed against another. Years of abundance could be set beside years of scarcity. Periods of stability could be contrasted with times of disruption. Time made patterns visible that were previously hidden inside memory alone. Progress and decline were no longer vague impressions. They became legible across decades. History began to take shape not as isolated events, but as a connected sequence. Calendars played a quiet but decisive role in this transformation. By dividing time into years and naming those divisions, they created a shared narrative structure. A year was no longer just the passing of seasons. It became a container for meaning. Events could belong to a year. A reign could be remembered by years. A famine, a celebration, or a reform could be anchored to a specific place in time. Time itself became a medium for storytelling. By the end of this phase, time had crossed an important threshold. It was no longer only something observed in the sky or assisted by simple tools. It had been structured. Years were defined, sequences were fixed, and long-term order was imposed on natural cycles. Nature still set the boundaries, but humans had begun to actively shape how time was organized, recorded, and recalled. This organization brought stability, but it also revealed limitations. Different societies used different calendars, each aligned to their own needs and environments. When cultures interacted through trade, diplomacy, or conquest, these differences became visible. A year did not begin at the same moment everywhere. Festivals fell out of alignment. Time, now structured, exposed its own inconsistencies. As connections between regions increased, these mismatches became harder to ignore. Coordinating agriculture, taxation, or ritual across larger territories required greater consistency. The desire for synchronization did not arise from theory, but from friction. Time systems that worked locally struggled when applied broadly. The pressure for refinement began to build. Yet at this stage, time still belonged to cycles. The sun continued to define the year. The moon still shaped months. Seasons remained the ultimate reference. Calendars did not replace nature. They depended on it. They translated natural repetition into human order, but they could not escape its limits. This translation was both practical and cultural. Calendars turned observation into structure and memory into system. They allowed time to be carried forward, preserved, and shared beyond immediate experience. In doing so, they quietly prepared the ground for the next transformation, one in which time would move even further away from the sky and deeper into human-made systems. Once calendars became established, they began to shape behavior in ways that went beyond timekeeping. A calendar does not simply describe time. It instructs people how to move through it. It tells them when to work, when to rest, when to gather, and when to wait. This gave calendars a subtle authority. Following the calendar meant aligning life with an agreed order. This authority became especially visible in agricultural societies. Planting and harvesting were no longer guided only by immediate observation, but by expected dates. A calendar allowed preparation before conditions arrived. This created efficiency, but also risk. If the calendar drifted, mistakes multiplied. Timekeeping errors now had consequences at scale. Different civilizations solved this problem in different ways. In Mesopotamia, careful sky observation remained central. Adjustments were made when mismatch became obvious. In Egypt, reliance on the solar year reduced seasonal drift or required long-term consistency. Each system reflected local priorities. Time was structured, but not universal. Calendars also became tools of administration. Taxes were collected at specific times. Military campaigns were planned around seasons. Religious festivals fixed collective attention on certain days. Time began to synchronize large populations. This synchronization strengthened institutions, but reduced flexibility. Missing a date mattered more than before. In East Asia, the symbolic layer of calendars deepened this effect. Naming years after animals did more than mark sequence. It assigned character. A year was believed to carry tendencies, expectations, even moods. This reinforced the idea that time itself had qualities, not just length. Calendars shaped perception as much as behavior. Importantly, these systems required constant oversight. Someone had to decide when a year began, when an adjustment was needed. This responsibility concentrated power. Control over the calendar meant control over public rhythm. Time became political, not because it was abstract, but because it organized reality. Disagreements over dates were common. Different regions followed different systems. Even within the same culture, calendars could fall out of sync. Timekeeping was stable within boundaries, fragile across them. As trade expanded, these inconsistencies became more visible. Historical records began to reflect this complexity. Events were dated according to local systems. Translating one calendar into another was difficult. The same year could appear different depending on location. Time, now counted, exposed its lack of uniformity. Yet despite these limitations, calendars transformed memory. Events could be placed in sequence. Reigns could be measured. Long-term change became visible. Time allowed societies to see themselves across generations. History became structured rather than episodic. By the end of this period, time had gained durability. It could be recorded, preserved, and transmitted. Calendars turned experience into continuity. They did not make time precise, but they made it legible. For centuries, time had guided human life without pressing against it. The sun rose, and activity followed. Darkness arrived, and the world slowed. Calendars brought long cycles into order, but within the day, behavior remained adaptable. People responded to conditions rather than commands. As towns grew into cities, the number of people sharing the same space increased dramatically. Streets filled, markets expanded, institutions multiplied. Daily life was no longer organized within small, familiar groups, but among thousands of individuals whose actions affected one another. In this environment, loosely interpreted time became inefficient. When many people depended on the same moments, disagreement about timing produced friction rather than freedom. Trade illustrates this shift clearly. In early marketplaces, exchange occurred when participants arrived. As long as both parties were present, the exact moment mattered little. In larger cities, however, markets operated on tighter expectations. Goods had to arrive together. Buyers needed assurance that sellers would still be present. Missed moments now carried economic consequences. Time began to acquire weight. Religious life experienced similar pressure. Daily rituals, once guided by natural cues, became increasingly formalized. Monastic communities, especially in medieval Europe, followed strict sequences of prayer, labor, and rest. These activities were distributed throughout both day and night, requiring consistency that sunrise and sunset alone could not provide. Prayer was not optional or approximate. It was expected to occur at specific intervals, regardless of season or weather. In these contexts, time stopped being descriptive and began to feel prescriptive. It no longer merely reflected what was happening in the world. It instructed people how to move through it. Early solutions attempted to adapt existing methods. Sundials were placed in public squares, transforming private observation into shared reference. Instead of reading shadows individually, people could now orient themselves collectively. When a shadow crossed a visible line, it signaled change not only in light but in expectation. A meeting might begin. A market might close. A ritual might start. Time began to speak in public. Yet sundials exposed the limits of natural dependence. They vanished under clouds. They failed at night. Their readings varied by location and season. As life demanded greater regularity, these inconsistencies became problematic. Cities required a sense of time that could persist beyond daylight and remain stable across conditions. Water clocks offered partial relief. By measuring duration rather than position, they allowed time to be tracked indoors and at night. However, water clocks remained fragile. Flow rates changed with temperature. Containers wore down. Someone had to monitor them constantly. Timekeeping still relied on human attention. It could be lost through neglect. The deeper transformation arrived not through accuracy, but through independence. Mechanisms capable of regulating motion without continuous human intervention changed the character of timekeeping. Weight-driven systems and escapement mechanisms allowed movement to be released in controlled intervals. These early mechanical devices were not precise by modern standards, but they introduced a crucial difference. Time could now proceed on its own. The earliest mechanical clocks appeared in Europe during the late medieval period, roughly between the late 13th and early 14th centuries. Their origins remain debated, but their function is clear. They were built for institutions, not individuals. Installed in monasteries, churches, and town halls, they were designed to regulate communal life rather than satisfy personal curiosity. These clocks were large, heavy, and often hidden within towers. Their faces, when present, were secondary. What mattered was sound. Bells rang at set intervals, cutting through daily noise. The ringing did not ask for interpretation. It announced obligation. Time became audible. This audibility altered experience profoundly. Under natural rhythms, moments arrived gradually. Dawn softened the night. Evening cooled the air before darkness settled. Mechanical signals disrupted this continuity. A bell rang, and a moment was declared complete or begun. Time shifted from something sensed to something imposed. With this shift came new forms of responsibility. When time was announced publicly, missing it became a visible failure. Earlier, arriving late could be explained by distance, weather, or uncertainty. Now, the same bell had been heard by all. Lateness acquired moral and social weight. Punctuality emerged as an expectation rather than a courtesy. Monastic life illustrates this change sharply. Missing a prayer was no longer a matter of misjudging light or shadow. It became disobedience to a shared schedule. Time discipline merged with moral discipline. Following time meant following order. Cities reinforced this pattern. As urban populations grew, individual rhythms collided. Mechanical time offered synchronization. It did not adapt to people. It required people to adapt to it. Bells rang regardless of readiness, fatigue, or circumstance. This uniformity was not compassionate, but it was efficient. Efficiency reshaped labor. Work was no longer judged solely by completion, but by alignment with schedule. A task finished late lost value, even if done well. Speed and timing became virtues. Time began to evaluate effort. This evaluation introduced pressure. Waiting became sharper. Anticipation intensified. People became aware of intervals, even before those intervals were formally defined as minutes or hours. Time pressed inward, shaping emotion as well as behavior. Mechanical time also changed authority. Whoever controlled the clock controlled the rhythm of life. Municipal leaders determined market hours. Religious authorities set sacred moments. Time became a tool of governance. Its neutrality faded. Public clock towers symbolized this authority. In cities like Florence, Paris, and London, clocks dominated central spaces. They represented order and coordination, but also power. To live within the city was to live within its time. Despite their influence, early mechanical clocks were unreliable. They drifted. Bells rang early or late. Disputes over correct time were common. Ironically, as time became regulated, it also became contested. Accuracy mattered less than consistency. A clock that was wrong but regular was preferable to one that was correct but erratic. This preference reveals something important. Mechanical time was valued not because it mirrored nature, but because it created predictability. Predictability enabled planning. Planning enabled control. Control came at a cost. Activities became less responsive to immediate conditions. Markets closed because the bell rang, not because trade was finished. Time overruled circumstance. Flexibility declined. Mechanical time also flattened difference. Daylight and nighttime hours began to be treated as equivalent units, despite vast differences in lived experience. This abstraction was quiet but profound. Nature's unevenness was being replaced with uniform segments. Resistance persisted. Rural life continued to follow natural cues. Agricultural work adjusted to weather, not bells. Mechanical time was strongest, where density demanded coordination. People moved between temporal worlds, adjusting behavior as context required. This coexistence created tension. A farmer entering the city entered a different time. A merchant leaving it returned to another. Time became situational. Over time, mechanical signals increased in frequency. Bells rang not only for morning and evening, but for multiple intervals within the day. The day gained structure. Experience became segmented. More beginnings, more endings. This segmentation altered attention. Long, uninterrupted stretches became rarer. Thought adapted to rhythm. Work adjusted to interruption. Time shaped cognition. Importantly, this transformation did not yet involve precision in the modern sense. Time was not measured with exactness, nor was it expected to be. What mattered was regularity rather than accuracy, repetition rather than calculation. Mechanical systems introduced rhythm into daily life, creating recognizable patterns that people could rely on, even if those patterns drifted slightly over time. Time had begun to take shape, but it was still broad, uneven, and tolerant of variation. By this point, time had clearly shifted from being a background condition to an organizing force. It structured movement, regulated work, and synchronized large groups of people who no longer needed to observe nature directly to know when to act. Yet this form of time remained communal and external. It was heard in bells, announced in public spaces, and enforced collectively, rather than felt internally or tracked individually. The transformation was decisive, but incomplete, leaving room for further tightening, refinement, and pressure in what would come next. As communal time became more stable, its influence moved inward. People no longer waited only for bells to act. They began to anticipate them. The expectation of a signal altered behavior before it arrived. Time started shaping intention, not just response. This was a subtle but decisive shift. Time was no longer only something that happened to people. It became something people prepared for. This preparation quietly reshaped daily habits, making future moments feel present before they occurred. Preparation introduced comparison. Arriving early or late gained meaning because there was now a shared reference. Lateness stopped being a vague delay and became a deviation. This deviation could be noticed, recorded, and judged. Time created a standard against which behavior could be measured. What had once been flexible now acquired edges that could be crossed. Labor changed under this pressure. In workshops and early manufacturing spaces, work was increasingly organized around fixed periods rather than tasks. Instead of finishing when a job was complete, people worked until a signal marked the end. Time, rather than outcome, became the unit of organization. This shift altered the value of effort. Duration began to matter as much as result. Work slowly detached from natural completion and attached itself to schedule. Payment followed this logic. Compensation slowly aligned with time spent rather than goods produced. The idea of being paid for hours rather than output required time to be treated as divisible and comparable. This did not require precise measurement yet, but it required consistency. Time became something that could be exchanged. Labor and time began to mirror one another. This exchange changed perception. Time began to feel scarce. When labor was measured by duration, losing time meant losing value. Waiting acquired cost. Efficiency gained moral weight. Time moved from background to resource. What was once endured now had to be managed. Religious life reflected a parallel transformation. Prayer times were no longer flexible windows, but fixed obligations. Missing a moment carried consequence. Repetition reinforced discipline. Over time, adherence to schedule became part of spiritual identity. Time was no longer neutral. It was meaningful. Sacred life became inseparable from ordered time. Urban life intensified these patterns. Streets followed schedules. Gates opened and closed at set moments. Curfews were enforced. Public order depended on synchronized behavior. Time became infrastructure, invisible but essential. Without shared time, the city could not function. This infrastructure extended into governance. Courts convened at set hours. Administrative deadlines appeared. Documents were dated with increasing care. Time entered record keeping. Events gained official positions within the day, not just within the year. Authority began to leave a temporal trace. As time hardened, personal experience adjusted. People began to sense the passing of intervals internally. Anticipation sharpened. Anxiety clustered around moments. Relief followed punctuality. Time entered emotion. It became felt even when no signal sounded. Inner life started to echo external schedules. Writers and thinkers noticed these tensions. Dante Alighieri structured journeys and punishments around ordered time, reflecting a world where sequence and duration carried moral significance. Time was no longer only physical, it was ethical. Actions gained weight through when they occurred. By the late medieval period, equal division of the day gained prominence. Hours began to be treated as uniform units, regardless of daylight variation. This abstraction simplified coordination, but distanced time from lived experience. The day became a grid laid over reality. Life increasingly moved within that grid. Yet even here, time was not fully precise. Variation persisted. Clocks disagreed. Signals drifted. What mattered was alignment, not perfection. People learned to live with approximate enforcement. Time was strict, but still imperfect. Time gradually moved from being something announced in public to something anticipated internally. People began to carry the rhythm of the day with them, adjusting behavior even in the absence of sound or signal. Anticipation, punctuality, and delay became part of everyday awareness, shaping decisions before they were made. Time no longer needed to interrupt life to be felt. It was already present in expectation, habit, and routine. At the same time, this internal sense of time remained tied to shared structures. Bells, schedules, and public signals still set the framework, but individuals increasingly responded to them in advance rather than in reaction. Time was experienced as pressure rather than interruption, as guidance rather than surprise. It had not become precise or personal in a modern sense, but it had clearly settled into daily consciousness, quietly reshaping how people moved, waited, worked, and judged their own actions. For centuries, time was trusted. It moved forward evenly and silently, the same for everyone, everywhere. This trust was not philosophical at first. It was practical. The sun rose. Shadows moved. Seasons returned. Nothing in ordinary experience suggested that time behaved differently for different observers. In daily life, time felt stable, predictable, and shared. Because of this, the idea of time as something absolute did not feel like a theory. It felt like common sense. This intuition was formalized most clearly in the work of Isaac Newton. In his framework, time existed independently of the events within it. It flowed uniformly, whether anything happened or not. Motion occurred in time, but time itself was unaffected by motion. This view fit perfectly with classical mechanics. It allowed calculations to work cleanly. It aligned with everyday observation. And for more than 200 years, nothing appeared to challenge it. Newton's time was not measured by clocks. Clocks were merely tools that approximated an already existing flow. Time itself was universal. Two identical clocks, no matter where they were placed, were expected to agree, assuming no mechanical error. If they disagreed, the problem lay with the clocks, not with time. This assumption became so deeply embedded that it shaped science without being questioned. The strength of this view lay in its invisibility. Absolute time did not need to be defended because it was rarely noticed. It functioned quietly in the background, supporting mechanics, astronomy, and engineering. It allowed cause and effect to line up neatly. Events happened one after another, everywhere in the same order. The universe appeared synchronized, but cracks began to appear when scientists looked more closely at light. Unlike sound or physical objects, light did not behave as expected. Experiments showed that its speed remained constant, regardless of the motion of the observer. This result was unsettling. In Newtonian physics, speeds added together. If someone moved toward a light source, they should measure light as traveling faster. They did not. This inconsistency could not be ignored. It was not a small error. It was fundamental. Either the experiments were wrong, or the assumptions about space and time were incomplete. The latter possibility forced a re-examination of something previously taken for granted. The decisive break came with Albert Einstein. Rather than adjusting measurements to preserve absolute time, Einstein questioned the assumption itself. What if time was not universal? What if it depended on motion and gravity? In Einstein's framework, time was no longer separate from space. Together, they formed a single structure. Events were located not just in space, but in space-time. The timing of an event depended on the observer's state of motion. Two observers moving relative to one another could legitimately disagree about how much time had passed between the same events. This was not an illusion or a measurement error. It was a physical effect. Time itself behaved differently under different conditions. At high speeds, time slowed. In strong gravitational fields, time slowed. This was not philosophy. It was prediction. These predictions were later confirmed. Atomic clocks placed on fast-moving aircraft ticked more slowly than identical clocks on the ground. Clocks on satellites experience time differently than clocks on Earth's surface. Without correcting for these differences, modern navigation systems would fail. Time was no longer abstract. It had measurable consequences. This realization overturned a deep assumption. Time was not a single shared flow. There was no universal now that applied everywhere. Simultaneity itself became relative. Two events that appeared simultaneous to one observer might occur at different times for another. This shattered the intuitive picture of time as a river carrying everything forward together. Instead, time became local. Each observer carried their own temporal experience, shaped by motion and gravity. The universe was no longer synchronized. Yet this did not mean time became chaotic. The laws governing time were precise. They simply replaced universality with structure. Time did not flow randomly. It flowed according to space-time geometry. This shift had profound implications. Cause and effect remained intact, but their relationships became more subtle. Events could still influence one another, but the ordering of distant events was no longer absolute. The universe lost its single clock. As physics absorbed this change, new questions emerged. If time could slow down, what did that say about its nature? Was time something that flowed, or something that existed as a dimension like space? Did the future already exist, waiting to be experienced? One response to these questions is known as the block universe view. In this picture, past, present, and future all exist equally within spacetime. Time does not move. Instead, consciousness moves through a fixed structure. The sensation of flow arises from perception, not from physics itself. This idea is unsettling because it contradicts everyday experience. We feel time passing. We remember the past, but not the future. The block universe challenges this intuition. According to it, the distinction between past and future is not fundamental. It is perspectival. Physics does not insist on this interpretation, but it allows it. The equations of relativity do not privilege the present moment. They describe a four-dimensional structure in which all events are laid out. Flow is not built into the mathematics. Another approach focuses on the arrow of time. While the laws of physics often work the same forward and backward, everyday processes do not. Glasses shatter, but do not reassemble. Heat flows from hot to cold, not the reverse. This directionality is associated with entropy, a measure of disorder. The increase of entropy gives time a direction. It explains why the past feels fixed and the future open. However, this arrow does not restore absolute time. It explains direction, not simultaneity. It tells us why time seems to move forward, not how fast it moves, or whether it moves at all. Meanwhile, cosmology introduced yet another layer. If time depends on the structure of the universe, then the beginning of the universe matters. In modern cosmology, time is often treated as having begun with the expansion of the universe. Asking what happened before that moment may be meaningless, not because it is unknown, but because time itself may not exist there. This possibility further destabilizes intuitive ideas. Time may not be infinite in the past. It may have a boundary. It may be a property of the universe, not a container in which the universe exists. At the same time, human experience of time remains deeply asymmetric. We feel duration. We feel waiting. We feel urgency. Psychological time does not match physical time precisely. Stress compresses it. Attention stretches it. Memory reshapes it. This mismatch raises another question. If physical time behaves in ways that defy intuition, why does experience feel so stable? The answer may lie not in physics, but in biology. The brain constructs temporal continuity in order to function. It smooths variation. It creates the illusion of flow. What emerges from all these perspectives is not a single replacement for absolute time, but a fragmented picture. Time behaves differently depending on context. In mechanics, in relativity, in thermodynamics, in cosmology, and in perception, time takes on different roles. The old idea of a universal clock dissolves. In its place is a network of temporal behaviors. None of them are arbitrary. All are constrained, but none are simple. This does not mean time becomes unknowable. It means it cannot be reduced to one story. The question is no longer, what is time? But in which context? At this point, time has fully escaped everyday intuition. It no longer belongs entirely to experience, nor entirely to mathematics. It exists at the intersection of structure and perception. And this escape raises a final tension that has not yet been resolved. If time is relative, structured, directional, and contextual, then what exactly is moving when we feel it passing? That question remains open. If time is not absolute, then the idea of moving through it stops being pure fantasy and becomes a physical question. This shift did not begin with imagination, but with logic. Once physics accepted that time could stretch, slow down, and behave differently under different conditions, it became reasonable to ask whether this flexibility had limits. Time was no longer a rigid background. It was something that could, at least in theory, be manipulated. One consequence of relativity is that traveling into the future is not speculative. It is already embedded in physics. When an object moves at very high speed or exists in a strong gravitational field, time passes more slowly for it compared to elsewhere. This means that a traveler experiencing less time could return to find that more time had passed for everyone else. No paradox is required. The traveler never leaves the present, yet arrives in a future that advanced faster than their own experience. This effect is not theoretical abstraction. It has been measured repeatedly. Astronauts on the International Space Station age very slightly less than people on Earth. Satellites must correct for time, differences caused by both speed and gravity, in order for navigation systems to function accurately. These are tiny shifts, but they demonstrate something profound. The future is not equally distant for everyone. The situation changes dramatically when the question turns backward. Traveling into the past raises problems that physics has not resolved. The most immediate issue is causality. If an event in the past could be altered, the chain of cause and effect leading to the present would become inconsistent. This is not merely a storytelling problem. It threatens the logical structure on which physical laws depend. Some solutions attempt to avoid contradiction by limiting what backward travel could do. One idea suggests that any action taken in the past would already be part of history, preventing change rather than creating it. Another proposes that traveling backward might create separate timelines rather than altering the original one. These ideas are mathematically interesting, but they remain speculative. No experimental evidence supports them. General relativity complicates the picture further. Certain solutions to Einstein's equations allow for structures known as closed time-like curves, paths through space-time that loop back on themselves. In these models, traveling to one's own past is mathematically permitted. The most famous example was explored by Kirk-Dell, who showed that a rotating universe could, in theory, allow such paths. The mathematics was sound. The physical reality remains uncertain. Most physicists suspect that nature prevents these situations from occurring. This idea is sometimes called chronology protection. The laws of physics may contain mechanisms that block backward time travel before paradoxes arise. These mechanisms are not fully understood, but their absence from observation suggests that something limits time's flexibility. Even without backward travel, the structure of time remains deeply strange. If different observers experience different durations, and if simultaneity depends on perspective, then the idea of a universal present dissolves. There is no single moment that everyone shares. Each observer carries their own slice of time, shaped by motion and gravity. This realization feeds back into the block universe view. If all moments exist within space-time, then movement through time may be less like traveling and more like occupying different positions in a fixed structure. From this perspective, questions about traveling in time become questions about access, not motion. Physics, however, remains cautious. Interpretation must not outrun evidence. The psychological impact of these ideas cannot be ignored. Human experience insists on flow. We remember the past. We anticipate the future. Physics does not erase this experience, but it does challenge its universality. The sensation of time passing may reflect how consciousness processes information rather than how time itself behaves. This leaves time in an unresolved position. It is flexible but constrained, directional but relative, deeply felt but not absolute. Physics can describe how time behaves under extreme conditions, but it cannot yet explain why time feels the way it does or why the present seems privileged in experience. Rather than closing the question, modern theories have expanded it. Time is no longer a single problem with a single answer. It is a set of related questions that intersect physics, cosmology, and perception. Each answer reveals another boundary. Time has not been mastered. It has been exposed. Time does not enter the human mind as a finished product. It is not delivered whole, flowing smoothly from moment to moment. Instead, it is constructed, quietly, constantly, and with remarkable flexibility. What we experience as time is not a direct perception of the world, but an interpretation built from attention, memory, expectation, and bodily state. This is why time can feel steady one moment and distorted the next, even when nothing external has changed. At its most basic level, the brain does not sense time the way it senses light or sound. There is no single organ devoted to time perception. Instead, time emerges from the coordination of many systems working together. Sensory input arrives, memory compares it to previous input, and anticipation projects forward. The continuity we feel is the result of this coordination, not a property of the world itself. One of the strongest influences on time perception is attention. When attention is narrow and focused, time tends to feel shorter. When attention is scattered or waiting for something, time stretches. This is not a metaphor. Experiments consistently show that people underestimate duration when fully engaged and overestimate it when bored or anxious. The brain does not measure time evenly. It measures change. Change is the key. When many events are registered in memory, time feels full and long. When few events are registered, time collapses. This is why childhood often feels expansive in retrospect. New experiences create dense memory traces. Adulthood, with its routines and repetitions, produces fewer distinct markers. Looking back, time seems to accelerate, even though it did not. Stress alters this process dramatically. In moments of danger, people often report that time slows down. Movements appear sharper. Sounds feel stretched. This effect is not caused by time itself changing, but by the brain increasing the rate at which it processes information. More detail is recorded per moment. Later, when recalled, the event appears to have lasted longer. This heightened processing has a biological purpose. Under threat, the brain prioritizes survival. Attention narrows. Memory encoding intensifies. Time seems to expand, allowing more perceived room for decision. The experience is vivid, but it is constructed after the fact as much as during the moment itself. Waiting produces the opposite effect. When anticipating an outcome without engaging attention, the brain repeatedly checks for change and finds none. This repeated checking amplifies duration. Time feels heavy. This is why cues, delays, and uncertainty stretch perception. The brain is active, but unrewarded. Sleep and dreaming reveal another layer. During dreams, Complex narratives unfold without reference to real duration. A dream that feels like hours may occur in minutes. The brain constructs sequence and causality without tracking physical time. When consciousness returns, the mismatch becomes obvious. This demonstrates that experienced time does not require external reference. Neurological studies support this. Damage to certain brain regions alters time perception without affecting intelligence or memory. Patients may struggle to estimate duration while remaining otherwise functional. Time perception is modular, not global. It can shift independently. Emotion also shapes temporal experience. Joy compresses time. Grief stretches it. Depression often produces a sense of temporal stagnation, where the future feels distant or unreachable. Anxiety accelerates internal pacing, making moments feel urgent and unstable. These effects are not secondary. They are central to how time is lived. Importantly, these distortions are not errors in a strict sense. They reflect adaptive processing. The brain adjusts temporal perception based on relevance. Time is not treated as neutral. It is weighted. Expectation plays a crucial role. When an event is predicted, the brain prepares. When the prediction is confirmed, the moment feels brief. When it is delayed or violated, time expands. This predictive model allows efficient interaction with the world, but it also means that time perception is always relative to expectation. This relativity becomes clear in routine. Familiar tasks seem to pass quickly because the brain predicts each step accurately. Novel tasks feel slower because prediction fails and attention increases. Time stretches to accommodate uncertainty. Memory ties these experiences together. What we remember determines how long something felt. Duration is often reconstructed after the event, not measured during it. This is why two people can experience the same event and remember its length differently. The philosopher and psychologist William James described this as the specious present, a short window in which experience feels unified. This window is not fixed. It expands and contracts based on context. The present is not a point, it is a span. Modern neuroscience echoes this insight. The brain integrates sensory input over brief intervals, creating continuity. Without this integration, experience would fragment. Time perception smooths reality into something livable. This smoothing, however, comes at a cost. It hides discontinuity. It creates the illusion of flow. Physics may describe time as relative or static, but experience insists on motion. This insistence arises from how consciousness operates. The brain cannot function without ordering events. Cause must precede effect. Action must follow intention. Time provides this order, even if its structure is flexible. Without temporal coherence, behavior would collapse. Coherence does not require accuracy. The brain does not aim to measure time precisely, but to use it effectively. Perception favors usefulness over correctness because survival and decision-making depend on relevance rather than exact duration. This is why time perception remains stable even when it is distorted. It does not exist to describe reality faithfully, but to organize experience in a way that allows action, anticipation, and response. As societies evolved, this internally generated sense of time increasingly interacted with externally imposed schedules. Mechanical and social systems introduced fixed rhythms that did not arise from nature or bodily cues. The brain adapted to these structures, learning to anticipate abstract signals rather than environmental change. Over time, inner time began to align with imposed rhythms, adjusting expectation and behavior to clocks, routines, and deadlines rather than light, fatigue, or instinct. This alignment, however, was never complete. A persistent tension remained between lived time and structured time. Fatigue, emotion, distraction, and attention continued to bend perception, even in highly regulated environments. External time could demand uniformity, but internal time retained elasticity. These two forms of time influenced one another without fully merging, shaping stress, creativity, memory, and identity. In this gap between structure and experience, time becomes deeply personal, revealing itself not as a fixed dimension, but as an ongoing act of mental construction. If time in the mind is constructed rather than perceived directly, then it is also vulnerable to limits. The brain can stretch and compress experience, but it cannot do so indefinitely. There are thresholds beyond which temporal perception begins to fragment. Fatigue, trauma, illness, and sensory overload reveal these boundaries, exposing how fragile the sense of continuity really is. One such boundary appears under extreme exhaustion. When the brain lacks energy, its ability to integrate events weakens. Moments lose their order. Duration becomes difficult to judge. People report that hours disappear or repeat themselves without clear memory. Time does not slow or speed up in a meaningful way. It becomes unstable. Trauma introduces a different distortion. During overwhelming events, the brain may fail to integrate experience into a continuous timeline. Memories become disjointed. Certain moments remain frozen, replaying without context, while surrounding time collapses. This is not metaphorical. Neurological studies show altered memory encoding under extreme stress. Time breaks not because it changes, but because integration fails. In these cases, the brain prioritizes survival over narrative. The usual flow of experience is sacrificed. Time becomes fragmented into isolated impressions. Later, when memory attempts to reconstruct duration, it encounters gaps. The past feels both distant and immediate, stretched and compressed at once. Illness can reveal similar effects. Neurodegenerative conditions often disrupt time perception long before other cognitive functions fail. Patients may struggle to place events in order or estimate duration accurately. The present loses its stability. This suggests that temporal coherence is an active process, not a passive one. It must be maintained continuously. Even without pathology, the limits of control are clear. No amount of intention can fully regulate time perception. Trying to make time pass faster often produces the opposite effect. Attention amplifies duration. Letting go compresses it. Time resists direct manipulation because it is shaped indirectly through processes that cannot be fully commanded. Technology has intensified this tension. Constant notifications, rapid context switching, and fragmented attention disrupt temporal integration. Days feel full but shallow. Time appears to vanish, yet memory remains sparse. This mismatch produces a sense of acceleration without substance. Experience moves quickly, but leaves little trace. This erosion of depth highlights an important feature of time perception. What feels long in memory is not what happened slowly, but what happened with richness. Dense encoding stretches retrospective time. Sparse encoding collapses it. The past feels shorter, not because it was brief, but because it was thin. This insight explains why novelty restores a sense of duration. New environments, unfamiliar tasks, and deliberate attention create temporal expansion. Time feels slower in the moment and longer in memory. This is not illusion. It reflects increased integration. The brain records more, yet even this cannot be sustained indefinitely. Novelty fades, attention drifts, the brain economizes. Time compresses again. This oscillation reveals the underlying constraint. Temporal richness is costly. The brain balances coherence against efficiency. At the deepest level, time perception remains asymmetrical. We can remember the past, but not the future. Anticipation simulates, but does not store. This asymmetry anchors experience. It creates direction. No matter how distorted time feels, it still moves forward in memory. This is not physics. It is structure. What emerges from all of this is not a failure of time perception, but its purpose. Time in the mind is not designed to reflect reality precisely. It is designed to maintain orientation, continuity, and meaning under changing conditions. When those conditions exceed its limits, time does not disappear. It fractures. This fracture is revealing. It shows that time, as lived, is an achievement rather than a given. It must be assembled moment by moment. And when the assembly falters, we glimpse the machinery behind experience. Time does not flow through the mind. The mind holds time together.